Hi guys, this is Abhishek, and in this episode, I'll be doing a hacker rank problem, algorithm problem, and I'll get you through the problem. I'll walk you through the problem and try to understand the approach in which we'll be uh, targeting the problem, tackle the problem. So let's get started. So as you can see here, this is the problem solving section. So this is the problem solving section, and uh, so let's try a easy problem. Let's start from an easy problem, kangaroo problem. So let's go through the problem statement first. Kangaroo. You are choreographing a circus show with various animals. For one act, you are given two kangaroos on a number line ready to jump in the positive direction, that is towards positive infinity. So there is a number line and the kangaroo has to jump a certain number of spaces, that is certain number of spaces. Two kangaroos are given and they will jump certain number of spaces in a positive towards the positive infinity. The first kangaroo starts at location x1 and moves at a rate of v1 meters per jump. So they move in two different speeds, and the first kangaroo is x1 moving in a speed of v1. The second kangaroo is x2 moving at a speed of v2. You have to figure out a way to get both kangaroos at the same location at the same time as part of the show. If it is possible, return yes, otherwise return no. So two kangaroos are jumping. So they are jumping in a different speed, and there might be some uh, condition in which both kangaroos meet at a certain location at the same time. So if that happens, then we'll return as yes as the answer to the problem. And if not, if that is never gonna happen, we have to predict that and answer as no. So let's get started with example that is given. For example, kangaroo 1 starts with x1 equals to 2 with a jump distance of v1 equals to 1. Kangaroo 2 starts with x2 equals to 1 with a jump distance of v2 equals to 2. After one jump, they both are x3, that is x1 plus v1 equals 2 plus 1, x2 plus v2 is 1 plus 2. So they both are the same position, that is x equals to 3. So our answer will be yes, since the both kangaroos meet at a certain point. So we return as yes. Now let's discuss see the constants and function description. Complete the function kangaroo in the editor below. It should return yes if they reach the same position at the same time, or no if they don't. Kangaroo has the following parameters. x1 v1 are the integers, starting position and jump distance for kangaroo 1, and x2 v2 are both integers, starting position and jump distance for kangaroo 2. Input format: a single line of four space separated integers denoting the respective values of x1, of v1, x2, and v2. In a single line, the input will be given in the command line interface, and we have to take it in by listening to the in of the standard input of the device. So they will be given as x1, v1, x2, and v2 space separated. Let's see the constants. 0 is less than equals to x1, less than x2, less than equals to 10,000. So x1 will always be less than x2. That is, the kangaroo 2 starts ahead of x1. So, and it will either the kangaroo 1 can start from position of 0 and up to a position up to 9999, and that is less than x2. X1 will be 1 less than x2 if it goes to the maximum. So the maximum number that we provided for x1 and x2 is 10,000, and for v1 the maximum number is also 10,000 starting from 1, and for v2 it's the same. Now output format is print yes if they can land on the same location at the same time, otherwise print no. Note, the two kangaroos must land at the same location after making the same number of jumps. Okay, so these points can be noted is that both of the kangaroos meet at the location at the same location after same number of jumps. So definitely here we can infer, what we can infer from here is that the kangaroo 2's speed should be less than the speed of the kangaroo 1, because kangaroo 1 will always start from ahead of kangaroo 2. Okay, given a sample input as 0342, sample output will be yes, because if the kangaroo 1 starts from 0 and kangaroo 2 starts from 3, as we can kangaroo 1 starts from 0 with the velocity with the speed of 3, and kangaroo 2 starts from 4 with the speed of 2. As we had input previously, the kangaroo 1 speed should be more than kangaroo 2 speed, because kangaroo 1 starts ahead of kangaroo 2. As we can see here, it is also given the same, and this is the probability that they might meet at a certain location after a certain number of jumps. So after doing some calculations, we can conclude that yes, they both meet at a certain location. The two kangaroos jump through the following sequence of locations, as you can see in the picture. From the image, it is clear that the kangaroos meet at the same location, number 12 on the number line, after same number of jumps, that is 4 jumps. And we print yes. So with another input, sample input, 0 to 53. In here, 0 is the location of the kangaroo 1 with the velocity of 2, and 5 is the location of kangaroo 2 with the velocity of 3. As we can see, the velocity of kangaroo 2 is more than the velocity of 2. So from the inference that we made previously, we can directly conclude that this is never going to happen, that they both will meet at the same location, and we can return no as the answer. The second kangaroo has a starting location that is ahead, further to the right of the first kangaroo starting location, that is x2 is greater than x1, because the second kangaroo moves at a faster rate, meaning vu2 is greater than v1 and is already ahead of the first kangaroo. The first kangaroo will never be able to catch up. Thus, we print no. So I will be coding in Node.js. You can follow up with whatever language you are comfortable with. Given the code sample here, as we can see, the x1 is greater than x2. I think this is something I wrote previously. Anyway, so if x1 is greater than x2 and v1 is greater than v2, we need not write x1 is greater than x2, because that is what is the given statement, that is a constant. If v1, if v2 is greater than v1, then we can directly conclude that no, the kangaroos will never meet at a certain location. This is the most basic code that we can write. So yeah, so as we can see, the sample test case passes. This is the most basic. This does not handle all the edge cases and many of the actual cases also. So I will conclude. I'll take a break from here for today, and we'll continue building this small program from tomorrow on. So thank you for watching. This is Abhishek from Abhishek. Goodbye.